So today I am going to finish this unit number 1 of operating system. So in this case, in this unit, we have already studied about the basics uh, of the operating system. Again, I am concluding this unit, overall conclusion in lecture number 8. You can see here. Just I am reminding all those terminology which we have already studied in total 7 lectures. So this is lecture number 8. Now these are again the different contents here. You can see the basics which we have, or the we can say the fundamentals regarding the operating system we have already studied. Likewise, we can say what is operating system. You are already aware what OS does, structure of operating system, evaluation of operating system, and under the evaluation of operating system, batch processing, multi-programming, time-sharing systems, operating system functions, main functions of OS, types of OS, single user, multi-user systems. So this is the overall, we can say, the contents of unit number 1. So again, we are going to emphasize over the basic terminology of the operating system again, because we are going to bind up this unit. So concluding here in lecture number 8, operating system, we are already aware, all this terminology even. Operating system is a software, we can say the system software, which makes a computer to actually work. Okay, without the operating system, we cannot work. So it is called the system software. It is a platform. It is a resource manager. So there are number of definitions which are used to define the operating system, and it is up to the user which type of definition he is going to consider, and whatever he is in mind, then accordingly he can choose the best definition among all. Okay, so it is the software that enables all the programs we use. Okay, because it is called the platform, we cannot use other softwares like other system software, application software, as well as the utility programs. Okay, so without the involvement, or we can say the installation of the operating system, we cannot work. So that's why it is called the platform. Okay, so it is the software that enables all the programs we use. So whatever we are using other programs, then it enable all those programs. So without enabling the other programs, we cannot work. Okay, so the OS organizes and controls the hardware. It is all right that operating system manages and controls the hardware, because the first layer is the hardware, and after second stage, the kernel, or we can say the operating system, and above these two, there is a other softwares which reside over the operating system, means over the kernel. OS acts as an interface. This is also right. Okay, OS acts as an interface between the application program and the machine hardware. So we can say the initial stage is we have the machine hardware. Okay, we have the hardware, and after that OS, and after that application softwares and application program. So this provides the interface. So example, there are number of examples of the operating system we are using currently: Windows, Linux, Unix, Mac OS, etc. So there are other operating system currently we are using on the mobiles, etc. So these are also come under the category of the operating system. Android based terminology we are using currently. This is one of the operating system which we are using in the various we can say the mobiles technology. Okay, so an operating system performs basic tasks such as controlling and allocating memory. These are various management uh, which are done by the operating system. We can use as the platform, as the resource manager, as an interface. Okay, so there are various, the definitions, and as per definition, we can here manage the perfect uh, definition for the OS. So there are number of basic tasks. What are the different tasks which are performed by the operating system? Controlling and allocating memory. it controls and allocates memory so that you can work where your file and folders will go in the memory, what will be the address for that particular file. Okay, so it provides the control system as well as allocate the memory area, okay, in the random access memory and also on the secondary storage. So prioritizing system request, okay, so we are working on a multi-programming, multitasking, multi-processing system. So whenever we want to work on a particular program or the task, then we can work easily, and we can also get the priority. We can handle priority bias, okay, so that we can execute the particular program on the behalf of the priority which we want to run at first. Okay, controlling input and output devices. There are a number of input output devices you are going to connect with your laptop or desktop. Okay, so how we are going to connect those IO devices? With the help of the OS, because this acts as a interface. So IO management, memory management, CPU management, file management. So there are a number of management which are controlled by the operating system. Facilitating networking. Okay, and nowadays we are using the networking everywhere. Then how this is facilitated by the operating system, we can say this. Managing file systems. Okay, whenever we are going to create any file and we are going to store on the memory, then all such will be done or managed by the operating system. So now you can see the structure of the operating system here. We have already done each and everything in preceding lectures, but just I am brushing up. Okay, so that you can recall all those. This is the concluding lecture. Now you can see here hardware, first stage, operating system. This comes under the category of the system software. Then system programs, okay, means some sort of here device drivers, okay, utility programs. So this layer, in this layer, just you are working on utility programs, etc. And above all, application programs. Okay, these type of programs which will be written by the programmer or the developer. So now this is the basic structure you can see here for the operating system. Okay, so from this diagram, it is pretty clear. You can see here. Now the structure of operating system with the preceding one here again continue elaborating hardware. What is this? There are a number of layers here. You can see hardware. What is this? Hardware consists of CPU. Okay, central processing unit means we have the motherboard. Okay, and after that motherboard there are a number of devices which are connected, but these are we are emphasizing on only on the very important we can say the electronic part of your system, or we can say the hardware. Okay, now who is writing on the chat? Sir, which part is kernel? Kernel is the central part. Okay, central part of the operating system. So we can say whenever again we will divide the operating system. Now here we are talking about the overall system structure. Okay, structure of the operating system. Then the central part, that is very important part, that is called the central part of the operating system, that is called the kernel. Okay, so with the help of the kernel, it you can write each commands. It sends the system calls. It sends various you can say signals to each and every part of the operating system. Even though we know that it is a system software, we always write a number of codes for that. But the central part of the operating system is called the kernel. Okay, now the basic structure I am telling that there are the four layers. First is the hardware. Hardware consists of CPU, main memory, IO devices, etc. Okay, these are very important. You can say the devices or various electronic here items or the devices here have the connectivity. And now software, another layer, the software operating system. So software includes process management routines, okay, memory management routines, IO control routines, file management. Okay, that's why it is called the operating system is called the resource manager. Okay, because it is here managing processes, memory, IO, and file management. So these are the basics. You must be aware by all these management, which will be done by the operating system. Now the third layer, we can say the system programs. We have already seen in this diagram here. You can you can check here. Okay, hardware, software means here operating system. So now whenever we will enter in this side, okay, inside the operating system, this is the overall structure. Okay, so inside the operating system, we have the kernel. Kernel, it is also a software part. Okay, inside the central part of this operating system, and above this system program and then application program. So that's why here just we are again explaining the same, uh, which is already given or mentioned on the diagram. So system program, this layer consists of compiler, assembler, linker, etc. Okay, so other type of system software after installation of the operating system, we can work on the compiler, the assembler, linkers, loaders, and other various system softwares. Okay, so these are called the third layer, and it contains a number of other softwares. And fourth layer, you can see here application programs. This is the one of the outer layer, and on this layer, mostly the user work on this layer application program. So this is dependent on user's need. So here we are going to develop various application programs as per the need of the users or need of the organization or the institute, etc. or a company. For example, just I am considering railway reservation system, bank database management system, etc. Nowadays, each and everything is online. Okay, most of the work has already been done online, and we are using a number of websites and other, software application software. Now, evaluation again, you can brush up. The evaluation of operating system went through 7 major phases. So there are a number of phases, regarding the evaluation or the starting or the initialization or the development of the operating system here. 6 of them significantly change the ways in which user assist computers through the open shop, batch processing, multi-programming, time sharing, personal computing, and distributed systems. Okay, so now you can see here, you can concentrate over this. So earlier we were using the batch processing and then multi-programming, then time sharing and personal computing, distributed systems. In the 7th phase, the foundation of concurrent programming. Concurrent programming, we can run a number of programs instantly. So were developed and demonstrated in model operating systems. Now here again you can see in this table the evaluation of the operating system. So major phases here you can see the open shop, technical innovations, the idea of operating system. So here we have the idea regarding the operating system. Just we are talking about 1954 here operating systems IBM 701 open shop 1954. So this is very old one operating system. Here we can see open shop, the idea of OS. Here we have the idea, technical innovations. So this is this was developed by the IBM 701. This was the name. Okay, in 1954. Now after this, the batch processing came into existence. Tape batching. Okay, first in first out scheduling. So here we were using the tape batching. So in the form of tape, just we are going to batch. Again, we were making or implementing some groups. Okay, so batching means just you are defining some programs of one type, similarly other type and third type. We are going to categorize. Okay, so we were doing the grouping here in the form of the tape, and that tape will be given to to the we can say the technical staff, and then we can run. So, but this was the case of old one in 1961. We were doing such things. Now, after the batch processing, multi-programming came into existence. Here you can see. So here processor multiplexing, we were using the processor multiplexing, indivisible operations, demand paging, input output is pooling, and priority scheduling, remote job entry. So now you can see here, this is again the history. Atlas Supervisor 1961, execute second system 1966. So this is this we can say the old cases here. Now again the evaluation of operating system, here you can see time sharing. After that we were using the time sharing systems, simultaneous user interaction, okay, online file systems. Here you can see the examples of some sort of operating system, multi file system 1965, Unix 1970. Now here you can see after the time sharing, you can check concurrent programming. Here hierarchical systems, extensible kernels, parallel programming concept, secure parallel language. And here there are various you can see here. Please ऑफ करें भाई, आवाज नहीं आना चाहिए, बैकग्राउंड वॉइस प्लीज म्यूट करें अब। RC 4000 system 1960, 13 Venus system 1972, 14 POS system here 1975. So here you can see the various systems we have already used here in years 1972 and 1975. So that time we were using the concurrent programming system. After that, personal computing came into existence. Here we were using the graphic user interfaces. So this was the case of OS 6 1972, pilot system 1980. And after that, distributed systems came into existence, remote servers we were using. So here you can see the file, there are number of file servers, and again Unix here 1982, and this is 1979. So there are various names, Amoeba system 1990. So this was based on the distributed system. So here we were using the remote servers, and with the help of the remote servers, we can work on different computers. Now you can see here again Windows XP versions for home and corporate or supports internet. Now currently you are working on the Windows operating system here. Multimedia you are using, corporate management capabilities. After Windows XP, the Windows operating system again, the Microsoft launched Windows ME 98 and 95. This is 32-bit operating system, graphical user interface, facility, multitasking, networking capabilities. You can see here Windows 2000. After this, Windows ME and 98, 95, this Microsoft launched Windows 2000. Again, this is 32-bit operating system. This has the facility of you can see here multitasking, multiprocessing, networking, internet services. And now Windows CE pared down for handheld computers, wireless communication devices, and currently we are using various Palm OS. Okay, these are the again Palm operating system, Palm compatible handheld computers or devices. Okay, mainly the Palm operating system just we are using in mobiles. Okay, and after that you are using the Android based operating system in your mobiles here. Now this you can see Unix, Linux, Mac OS. We are again using such type of operating system. Even though we know that Unix and Linux, these are the old versions, and again upgraded as per the new technology. Unix currently we are some of the organization which are doing the powerful programming, they are using the Unix operating system as well as the Linux. So you can see here in the engineering college and other, various companies, they are using the Linux operating system. Even you are also using this Linux operating system so that you can work comfortably whenever you are going to do such any programming, C, C++, or you can use this platform. And this is the another machine here. You can say Mac OS. There are several machines which are using this Mac operating system. This also have, the different characteristics: multitasking, networking, powerful multimedia capabilities. Now this is again the elaboration about the, you can say, batch operating system, when we were using the batch operating system at all. Okay, now I am not explaining this again, batch operating system. So here you can see in this diagram, common output devices were line printers, tape drives, and card punches. Now you can see here, this is the main memory area. Okay, so this is the user program area. Okay, here you can write the program. Whenever you will write any program on your monitor, so it will be occupied here by the RAM, random access memory. So whenever we will talk in context of the operating system, then we will always, discuss regarding the main memory. Okay, random access memory or the main memory, not about the secondary memory. Whenever the system is working, then always we will here discuss about the main memory. So this is the major, you can see the area which is uh, you can here dedicated for the user. Okay, and this upper layer, here the operating system will reside. So as well as you will switch on your operating system, switch on your system, laptop or desktop, whatever it be, or the even mobiles, then this upper layer will be occupied by the operating system, and major area you can use here. Okay, this is the area dedicated for the user. So this is called the user program area. Now the multi-programming system, if you are able to execute a number of programs simultaneously, here you are working on a single processor and, executing a number of programs simultaneously. So here we can also use, it is not necessary that you will use the single processor. Earlier we were using the single processor, but nowadays you are already aware there are a number of processors which are inbuilt together. And whenever we will run a number of programs, then it will go to the various processors. And here you can see the number of processes reside in main memory at a time. Okay, whenever you will write the program and execute, then it will go to the main memory. And you have already seen the defined area for the user, dedicated area. Now here you can again see OS picks and begins to execute one of the jobs in the main memory. So the operating system will pick one program at a time. Okay, so it will execute one program, one of the jobs in the main memory. If any IO wait happened in a process, then CPU switches from that job to another. Okay, so if there is a waiting condition in case of the IO, then it will switch to the CPU. Hence CPU, here we can say, it will not remain idle at any time. The work is continue for the CPU. So we can say that every time CPU works. Now here you can see again, this is the operating system area. Here we can, uh, occupied the area by the job 1, job 2, job 3, job 4, job 5, like this. Okay, so this is the main memory. So this is the user defined area, and this is the already fixed area for the operating system. Now there are various advantages. You can see here efficient memory utilization in case of the multi-programming. Okay, so what are the different advantages for the multi-programming system? Efficient memory utilization. Here you are using the memory because you are running more than one program. Here you can see one of the example, 5 jobs, or we can say 5 programs are running together. Okay, so this is the fixed area by the operating system occupied by the OS, and now 5 programs are running together. So we can say that it is a multi-programming system. Now there are various advantages. Efficient memory utilization. Okay, here we are using the remaining memory, okay, of the main memory, out of main memory. Throughput increases. Now as the more number of program will run, then throughput increases. CPU is never idle. Okay, so uh, it will busy every time. It will remain busy, CPU. So performance increases. Okay, so we can say it is more efficient. Performance also enhanced. Now time sharing system, you are already aware, time sharing or multitasking, okay, is a logical extension of the multi-programming. So whenever we will extend this multi-programming, then we can say it is a multitasking or the time sharing system. Here again, multiple jobs are executed by switching the CPU. Okay, so now there is a game of the central processing unit. Now we can execute a number of multiple jobs here, number of jobs at a time. So the CPU time is shared by different process. Okay, because a number of jobs are running. So CPU timing is shared by number of jobs or number of programs or number of process, we can say. So that is why it is called the time sharing system, because the time is shared by different jobs of the CPU. So time slice is defined by the OS. Now this is the function of the operating system. Then operating system will decide to allocate the time, or we can say the time slice. So this is defined by the operating system for sharing CPU time. Okay. Now there are various examples of the OS which were using the time sharing criteria, or currently again the same terminology we are using, multi Unix, etc. So nowadays we are using a number of operating systems which have all the facility, not only one. It is a multi-programming, multitasking, time sharing, multi-processing. Okay, so it have all these characteristics. So operating system, various functions we are already aware: program creation, program execution, IO operations, error detection, resource allocation, accounting, protection. So there are various, we can say, the functions of the operating system. Overall functions we have already seen, and now you can see here. Allocation and assignment, other functions: allocate resources. Resources are, you are already aware, there are number of IO devices which are connected: CPU, memory. Okay, so these are the various resources. So these resources allocated, how these resources allocated by the different programs or the jobs with the help of the operating system. Okay, control primary memory allocation. So such type of things will be controlled by the operating system. Scheduling process, inputs and outputs. Okay, monitoring keeps tracks of users and jobs. Okay, operating system always keeps tracks of the users and jobs. How many users are working, what type of job assigned to each system. So this have all such type of characteristics. Managing multiple users, then it is called the multi-programming, multitasking. Okay, but because it allows multiple users, more than one user can work. Allow 2 or more programs to share resources. You can write, in case of the multi-programming, CPU executes one program while managing input and output of other program. So there are various facilities you can see here. Multi-threading, the capability of an operating system to execute different parts of the same program. If the program is long, okay, so it contains various functions. Okay, then each function we can say acts as a thread. That is called the threads. So at the same time, we can see here the capability of an operating system to execute different parts of the same program. Different parts means there is an involvement of number of functions in a big program. Then those function acts as a, we can say, threads. So this is called the multi-threading here. Virtual memory creates efficiency by dividing the programs into small sections. Efficiency, how we are creating the efficiency by dividing the programs into small sections, that is called the pages, and reading them into memory only when needed. as we have already told earlier that if the memory, main memory is less and our program is very huge one or very large, then the operating system, how the operating system will manage, it will divide your whole program. Suppose you have the main memory 4 GB and your program, or we can say the any software or the project is of 8 GB, then the operating system will manage this. It will cut or divide your program into small sections, that is called the different pages, and each page, or we can say the each section, will go for the debug purpose or the compilation or the execution. Okay, so this is called the virtual memory criteria, so that you can run your 8 GB program even though you have only 4 GB of RAM. Okay, so uh, this will be managed by the operating system. That's why it is called the virtual memory system. Okay, so this is one of the most important, we can say, the characteristics of the operating system. Time sharing, we are already aware, allows computer resources to be shared by many users. Okay, there are a number of users working together at a time. Then there are number of resources. So then how the resources will be shared by many users, that is called the time sharing. Okay, multiprocessing. Multiprocessing means execute 2 or more instructions simultaneously in a single computer system by using multiple CPU. So on a single computer system, we have the single motherboard, but there are multiple CPUs which are interconnected to each other. Okay, whether it in the form of the loosely coupled or hardly coupled. Nowadays, we are using a number of processors and that is inbuilt on a single chip. So that is called the multiple CPU. So how the instruction works simultaneously on a single computer, we can see that is called the multiprocessing. Now language translation, we are already aware. We can run other system software over the operating system. Compiler, we are already know, translate source code into object code all at one time. Okay, interpreters, source code one line at a time. So this is more, we can say that quality wise interpreter is better than, but compiler, if we will talk regarding the speed, then compiler is better. Now there are again single user system, multi-user system. These are the types. Now the time is going to finish. Just I am winding up this. So single user, only one user at a time can work on a machine. Here in the next case, you can say number of users can work at a time. DOS, it is a single user. Okay, multi-user, Unix, Linux, and other operating system we are using. These are the multi-user systems. We can work together. Okay. So this is the overall, we can say, the conclusion. Now I am taking your attendance here. Any question, please welcome. So now unit 1 has finished today, and I have already concluded regarding the unit number first of operating system. And today I will try my best to upload the unit number 1, the PDF form, okay, on the Google Classroom.
ओके सर. सर ऑफलाइन एग्जाम हो सकता है क्या इस बार?
Maybe, yes. As I think you are already aware that in the newspaper you can read such type of information, what is going on. Okay.
जी सर.
तो उसी तरीके से तैयारी करें. ठीक है. Thank you very much.